Hey guys, what's up? How's it going? I hope everyone's doing all right. Essie Woods, I see you're in the chat there. Good to see you. Hope everyone's having a good morning or night or afternoon, wherever you're at. Sorry about the late start today. I must have been catching up on the sleep that I missed out on the other night because I got no sleep 2 nights ago, and then I don't even know how I stayed awake yesterday, but I did. So I must have caught up on that. Langors and Voxriffs, how's it going, guys? Good to see you. Voxriffs, I saw your message in Discord too, by the way. So we will take a look at your code on Thursday. Yeah, Thursday morning. Maybe tomorrow. I'll see. And it'll probably be towards the end of the stream, but I'd love to do that because that'll be fun to do. So first thing I want to mention today is, as you guys know, we were working on block lighting yesterday. I found some good resources and I'm pretty close. I'm like this close and I think we're almost there. But I wanted to mention one thing about refactoring again, because somebody was in the Discord talking about refactoring and stuff, or making clean code, I guess. And they jumped to like design patterns. And I think that's probably a bad place to go. If you're ever coding, don't immediately jump to design patterns. I think most of you guys know that and agree with me on that. But like this loop that I had, remember it was this huge, ugly loop. This was for all the blocks, like loading blocks and everything. And I had all of this code that was just so repetitive. And I kept saying, oh, I got to refactor this. And I mentioned in stream, I was like, oh, I see how I could refactor this too. And this is what it used to be. And you'll see I removed this whole chunk, turned into this. And I actually removed these comments too, because they're not necessary. I removed this whole chunk. It turned into just this. I removed this whole chunk. It just turned into this. And then I rolled all of that stuff up into just this small loop. So when I say like refactor stuff, this is what I mean. You basically wait until you see those patterns. And once you see where the patterns are, you can just wrap it all up, because typically you're doing like either a repetitive movement, you're doing the same thing over and over again. Oh, that's a function or that's a loop. Or you're doing some other type of thing, like crazy logic. And then you realize, oh, I could split this up into separate objects that all like implement some sort of interface or something. So it's usually, it'll reveal itself to you if you just wait enough time. Anyways, though, I found this question and it talks about block lighting very good. I was doing it horribly wrong. So I understand why Notch did it with the flat shading now too, because it's actually a lot easier to do that first, I think. But basically the idea is, if we look at Minecraft's actual wiki too, they have a good thing. The idea is, first of all, solid blocks don't have a light level, which makes sense. That's like a duh moment, right? Solid blocks don't have light levels. Why? Because they're solid. So we only have to worry about air blocks. And what we do is we basically say, hey, if we're an air block, we look to all of our neighbors and we take the brightest neighbor and take 1 minus that. So this is a torch. So it has a source light level of 14. So this one would look at all of its neighbors, and it sees the torch is the lightest level, so it takes that one, and then it takes that -1. And then we add him to like a queue that's like, oh, now we need to check his neighbors. And then we would also check him, and then he would take the torch, and then he'd be like, oh, I'm 13. Then we have to add all his neighbors to a queue. So now we have to check these 3 blocks, and then we keep going, and we keep going. And we get this kind of recursive function that basically checks everything and makes sure that we have the appropriate thing set. So how does this work? I don't like the way I did it right now, and it's not working properly. So we may have to take a look at that and try and fix it up. So let's see what I got right now. And also the way that I'm doing the colors and stuff, we're gonna have to fix that because I don't like that either. But I want to get this done, and I want to get cube maps in the game so that we can move on to hopefully biome generation or something. So you can see that these are all uniform light level, because I'm sort of doing it right, but it's not very good. If I remove a block, it kind of updates it, but it's not updating it right, because if we keep going down, what should end up happening, oh, and then yeah, I have this big hole, and so what should end up happening when I dig down into here is all of these blocks should get updated, because they should see that this light level is different, and then they should all update automatically, but they're not. So I clearly have some stuff that's wrong. So we're going to take a look at my algorithm and see if we can figure out how to make it a little bit more concise and see if we can make it work properly. So the basic idea now is when we queue up a chunk, we do a couple things now, right? So before, when we queued up a chunk to be generated, like for all of its data, we would go through a couple phases, right? We have this fill block data command, which basically says this gets sent to like all the threads. And I think the priority of the commands too, because they all have different priorities. Yeah. It goes, do I have it here? No, I have it somewhere else. Okay, here we go. This is the order of the priorities. So number 1 priority is saving block data. So if a chunk gets unloaded, we save the data. That's the first priority. That way we get that memory freed up, and then somebody can use it for the next step, which is filling block data. That's where we either deserialize the data from a file, say the chunk was already saved before, so then we're just loading that in, or we generate it using our biome generation, however that may work. Then I added this new one, the third priority, which is calculating lighting. The reason we need to calculate the lighting before we tessellate is because when we tessellate, we have to send the light data back to the chunk. But this is cool because if we can calculate lighting and then tessellate, whenever we do a block update, we know we don't have to run this step anymore, right? And so that's the cool thing. These 3 steps are only ever run when we're either loading a new chunk in or we're generating a new chunk. Then from then on out, it's like if we ever have a block update or if we ever have a light update, any sort of update to a chunk, we only have to run the retessellate because the block update will implicitly recalculate the lighting for any lighting that needs to be recalculated around it. And then we will just retessellate, and that will update our vertices and immediately send those to the GPU. So that's sort of the priorities, and you can see it happening here too. Right here. One second. SE Woods is a general programming pattern in the Mario series OOP. The component pattern is design pattern. If you have a brief answer. Yeah, it's I was going through sort of a phase of like learning different things. Yeah, OOP is a paradigm. Yeah, you could say that. Well, it is. Yeah. And component pattern is a design pattern. That is true. But I was kind of going through like my own learning journey phase when I was doing the Mario series. So you'll kind of see it morph in the beginning from like a very solid like OOP kind of that's the way I am. And then towards the end of it, I'm using a lot more public member variables, getting rid of my getters and setters, and sort of doing that. And that's because I started coding in C++ and saw like simpler is way better 90% of the time. So if I were to do that again, I'd probably do it massively differently, which is a shame because these are the types of things that you only start learning about once you start coding bigger and bigger projects. But yeah, it kind of evolves as you go on, right? I think you meant Wish Java had properties like Python. Is that like C# properties too? And yeah, I did start with public variables. Yeah. Change stuff in Minecraft series when you start moving to assembly. Oh boy. Basically like C#. Yeah. Okay. Properties are nice too, but I've done a spiel on those too because C# properties can be dangerous as well. It's sort of like C++ overloading operators. A simple plus operator can be doing something you have no idea. Same thing with C#. You can be doing like this command.block data. In C++, we know that this is literally just accessing this pointer. But in C#, you could be doing a whole ton of work without even realizing it. And that kind of scares me. So they're good and they're very useful in certain cases, but you have to be careful with how you use them. So, okay. But anyways, so we can see how all this plays out inside of these commands. So when we hit command type fill block data, and talking this through out loud too, just sort of helps me reiterate how this algorithm is working. So that's sort of another reason why I'm going through this again. So when we hit command fill block data, first it checks to see if we already have it. If we do, we just deserialize that. If we don't, then we say generate it. So that fills out this pointer with a bunch of data that we can use. And then we say queue the lighting calculation command. So then this thread, whichever one just handled this, goes ahead and queues it itself. It says change the command's type to calculate lighting, and then just requeue the same command, and we tell it to begin the work. This false parameter just says launch only a single thread from our thread pool. So that's all that's doing. And then when we say calculate lighting, which is the next command, so theoretically this would start immediately, but it could probably wait because it has lesser priority until all the other chunks are done generating. So that could wait a little bit. Then we call this chunk calculate light levels. And once we finish doing that, we say, okay, now we can start tessellating vertices. And so this queues up that command. We begin the work, and then we go ahead and we say test light the vertices, which just generates all of our render data, which just uploads that stuff to the GPU immediately. So it all kind of goes through this. And then on the CPU side without the threads, so on the main thread, what ends up happening is we either just say call this command and he sort of goes through and launches the rest of the commands, or we just say launch this command because we just need to test light. So we never really go through the in-between steps, which is the calculating lighting. Maybe I'll change that in the future because there will be some reason to. But yeah. Okay. So how does calculate lighting work? Because that's what we're focusing on, and I need to fix up that algorithm somewhat. And this file is getting very big. I want to move a lot of it around. That's actually a to-do if we look. To-do, clean up the code in chunkmanager.cpp, but I haven't gotten around to that yet. So that's not as important priority, right? It can be a big file for now. Okay, anyway, so if we go down to right here. So this is calculating the light level. Yep. And okay, yeah, and we have to do this from the top to the bottom because we do that's another thing too. So there's also another aspect to lighting, which is skylighting, right? A skylight is basically any block that's unobstructed going up. So if you have, imagine, right, you have air block, solid block, right? These three blocks are skylights, and then say you had another block underneath. This one is not a skylight, right? Because he has a block above him. Unless this is glass or another transparent block, this one would no longer be considered a sky block. So this is sort of another thing that we have to worry about. It makes the lighting calculations a lot easier though, because skylights just sort of take on the source value of whatever they are, and then we can sort of go from there. And it's pretty easy to do if you think about it. We just have to make sure that we start from the top, which is why we go from world chunk height -1 down to 0. And then what we do is we basically say if we're on the top level and if we hit an air block, then we're going to say set this to a skylight. And the way I have that is another magic number that I need to fix eventually. But basically we just say 31 ORed with 32. In our game, a light level can go up to 31. And so this 32-bit that we're setting is basically just saying this is a sky level. So then we can check and see if a block if a block is a sky block just by anding the light level with 32. And if that returns true, then it's a sky block. So then what we can do is we can say, well, if we're not at the top, then we need to take the maximum of our neighbors, or we need to set it to a sky block if it is a sky block. So first we check if it's a sky block because that's less work, and we want to do less work if we can. So we say get the top neighbor, so whoever the block on top of us is. And since we're one below, we shouldn't have to worry about like getting an out of bounds exception here because we should be in a valid place in our array. I guess I could put an assert in here. Maybe I'll do that later, but we shouldn't have to worry about that. So then we get the top neighbor's light level. So we basically say, if it's an air block, then we and it with 31. That way we strip out the 32-bit if it's a skylight. But if it's not an air block, we just set it to 0. That way they get sort of like the minimum. So then we can check and see if it's a sky block by just anding it with 32. And we say if it's a sky block, then we set the light level to another skylight block, right? So now this is 31, 32, the max light level, and it's ORed with 32 so that we know that. Otherwise, if it's not going to be a sky block, then we have to take the maximum of all of our neighbors up, down, forward, backward, left, right, -1, or 0. Because if we go negative, then we have to make sure we clamp it at 0. So what I do here then is I just do sort of the same thing I did here. I get the left block, then I check if it's an air block. If it's an air block, I get the light level anded with 31, otherwise it's 0. Same thing with right, bottom, front, back. And then I do this giant GLO max thing where I basically do the maximum of the left, right, top, bottom, front, back, and subtract 1 from that, and the maximum of that and 0. And that's it. And then I just set the color to white by default. So that one I'm pretty confident in. I think this should be working fine, and we'll do a test to make sure that this is working fine too. Let me catch up on chat a little bit too. Voxriff, since I'm using OpenGL 4.6 anyways, did I consider using compute shaders? I received the GPU wasn't being used to its fullest potential. Yes. So the way I'm thinking of using compute shaders right now is for the thing that the CPU is bottlenecking the most at right now, which is culling. Like frustum culling, I guess I should say. That's literally the spot where like our CPU is getting the hottest right now, and it can really slow down once we get to a lot of chunks. So I want to offload that to the GPU. Just to kind of take that work there, and the GPU should be able to do that really fast because that's like a parallel algorithm just by nature. So it should be able to just blast through that. So yeah. But that's not as important because performance is pretty good right now. So I'm just trying to focus on getting the features in. Miri4F, hey there, how's it going? And Essie Woods, when people say design-oriented programming, I think that's data-oriented programming. Is paradigm like OOP? So DOP is not the same as design pattern. No, DOP is data-oriented programming, I believe. Yeah. Right? I think. DOP is. Maybe I'm wrong. Okay, yeah, data-oriented. Okay, cool. And Langor is, yes, design pattern is a reusable solution to a design. Yep. Okay, cool. So this is how our lighting solution works. Let's make sure that this part is working correct. So setting and removing blocks is a little bit different because that's kind of harder to do. But we can check and see if this is working right. And I will do that by doing this. We'll dig out like a hole, and there should be some blocks above it if I don't crash immediately. So this is another thing. There's some crashes happening because of our, yeah, I think it's because we get into a lock, an infinite lock or something there. So we'll wait a second for all the chunks to generate, then we'll start digging. But that's something I got to check out too and fix. You just have no knowledge or experience about DOP. DOP is really easy. Like if you look at a lot of people, they make it sound super complicated, but it's really not that bad. It's literally just coding. It's literally just coding with thinking about the problem. So you basically just solve the problem at hand, sort of like what we're doing here. Like this is data-oriented programming, right? We're just saying we have all this data. I need to set the light levels. How do I do that? So there's a little bit more to it, like thinking about cache friendliness and stuff, but it's not stuff that you really have to worry about too much when you're getting started, at least. Once you start working with it more, you probably do have to worry about it a little bit more, but yeah. Okay, so if we do this and we don't crash, oh, this is annoying. I have to fix this. Let's try this again. So if we do this and we don't crash and then I save it, what we can do is we can see if I rerun this, if that whole area gets dark. Because right now when I'm like updating blocks, as you can see, it crashes first of all. And the way I'm calculating the lighting there, I'm pretty sure is wrong. And so that's what I've got to fix. But I'm pretty sure what the algorithm that I just went over, I'm pretty sure that's perfectly fine. Just got to make sure that it's working okay. So I'll update these slower to make sure that we don't hit any crashes. I'm not sure why that's crashing too, because it's like I'm locking it there specifically so that we don't crash, so that we don't go into like a race condition, which is weird, but whatever. I guess that's the way it is. Okay, I'm just going to leave it there because I'm afraid it's going to crash. So we'll save it. Let's see if that works. So it should get darker under there because I'm basically removing stuff and the first algorithm should run and then it should work right. So these are all skylights, which is why they're all white now. And it does get darker. I think, does it look like this is getting darker? I can't tell. So this is really bright. Yeah, I think this is getting darker back here. It technically, if we were to go 31 blocks, let's go a little bit further and see if it gets even darker too. If we were to go 31 blocks, it should go to 0. See, and then it's going to crash. Okay, first of all, let me remove the code that's doing the updating lighting inside of our update blocks. That way we can actually dig. And we'll fix that later. So right now, I've got like a recursive algorithm that updates lighting. It's like set block internal and get block internal. So let's look for that right here. Yeah, so we'll just get rid of this for now, and then we'll get rid of this for now. Okay, so let's do that, and now we should be able to just play the game. And how's it going, CGO Clan, aka Mr. Hecker? Did I check the texture issue? Not yet. We're doing lighting first. And 8th game, hey, how's it going? Hope you're doing all right. Voxel riffs, yes, it does it very subtly. I'm not sure what you're mentioning there, but it's okay. So let's see if we can dig further and then see if we're actually getting darker blocks here, because it should be, but I'm not completely sure. And then we'll just like go around this way, I guess. And so I think what should end up happening is once we get to the bottom of our light, it should decrease to whatever we saw there. I think that is a 0 light level. And right now it's just like breaking when I update blocks. So yeah. So, okay, that's weird. So it just immediately cuts off here. But maybe is this 31 blocks though? I don't think this is. This is like, does not look like 31. These should be taking the brightest value of their neighbors, which would be this guy, and then just doing that -1, which I have a hard time believing is this much of a change, especially since you technically need to go 31 blocks before you hit that. Let's run this again. Let's just see. Maybe I just didn't let it save or something. I don't know. We'll see. Is it a chunk border? Ooh, that's a good idea. I should check that. And 8th Gabe. Yo, Gabe, I'm doing good. What about you? That's good. Oh, AK Dev. Okay, cool. Let me change the name. I wasn't sure there. It's a different dimension with completely different physics laws. Yes, it really is. Okay, so it's definitely not an error. I wonder if this is a chunk border, like you said, Voxel riffs. Let's see. So this is which dimension are we in here? This is Z dimension. Okay, so this is 153.209.47 to 153.209.46. I think you're right. I think this is definitely a chunk border because chunk border should lie on 16. Yeah. Okay, that makes sense. That makes perfect sense because if we do 48 is a multiple of 16, so this would be the edge, I believe, and then this would be the next chunk because this would go up to 40. Yeah, since we do a floor 47, I guess. So let's check that out and fix that up. Thank you. Yeah, 48. So if we go into the chunk manager, we should be able to just fix that up pretty easily. I think that was in a calculate lighting function or something like that. What do we call? Calculate light levels. Okay. So let's go find that. I hate how, since I don't code in like traditional C++ ways, if I do a control click on this, it doesn't usually take me to the actual function, which is really annoying. Visual Studio needs to fix that, but whatever. So, yeah, I use this function, which should theoretically go and look for its neighbor, but this is a problem. Okay, because this is kind of hard to do if we think about this. So we have this multi-threaded, right? So, oh, cool. AK Dev, thanks for following. So we have a problem if we think about this, right? This is multi-threaded. So we can be updating multiple chunks at once. The way I got around worrying about like removing interior faces and stuff, if we were updating multiple chunks at once when it comes to the render data, is I just make sure to fill out all the blocks first so that we know which blocks are where. But this is a little bit tougher because if we're calculating the lighting at the same time, then what can end up happening is like we finish this chunk. Here, let's draw this out just so that we can see this a little bit more. And I'll check the chat real quick. AK Dev, which feature bug are we working on? Lighting, yep. And FlareTube. Hey Gabe, how's it going? And it's going good, FlareTube. I hope you're doing all right too. Good morning as well. So let's go to the drawing screen real quick so I can explain this a little bit more. So what's happening here, because technically I am checking bordering chunks and stuff, but let's say we have a chunk here and a chunk here, right? And we're just going to look at these on a 2D basis because it's just easier to think about that way. So we have thread 1 working on this one, and we have thread 2 working on this chunk for calculating lighting. They're both calculating lighting, right? Now let's say thread 1 is down to here with the calculating lighting, and then he gets to this block. He goes and he checks this chunk's block. Well, this chunk's block says it's 0, but that's because thread 2 is up here right now doing its calculating lighting. So it hasn't gotten to this point. Really, this isn't 0. Really, this is 5. But now thread 1 doesn't know that because he just checked it and he thought it was 0. So what's the easiest way to do this? I mean, the easiest way to do this is we could just, and this might be the best way, we could just say, okay, we have 2 stages of lighting, right? We have the first stage, which is internal calculations. Internal calculations just calculates all of my stuff. We don't care about border chunks. And then we run a second phase, which says just go around the borders of my chunk. And then we just check these borders against all neighboring chunks to update these block levels accordingly. But this could still run into a problem, couldn't it? I'm trying to think of this, because what if this updates and finds out that this block was brighter than this block? So this block was brighter than this block, so then I update this, which ends up updating this, which ends up updating this. And now all of a sudden, well, actually, is this a problem? I don't think this is a problem, because then it would only expand internally, right? We should never expand outwards, because if he's the brightest, then these ones are all going to be brighter just by fact of how this works than these ones. So this should only ever expand internally. But if we have a light level of 31, that means that, say, this was 31 and this was 5 before. Let's think about this. Let me get this eraser real quick. Okay, so if that was 31 and this was 5 before, what ends up happening is now all of a sudden this one gets set to 30, and then it kind of bubbles over, and let's say it bubbles all the way to this edge. Now this edge is actually going to be lighter. It's going to be like, if that was 30, then it would go down 16, so this would be 16. Well, what if this light was 0 before? Now all of a sudden it updates to what it was here before, which was 0, but now this is 16, so now we have the same problem, just in another dimension, or another chunk. So how do we update things without this happening? Actually, I think the problem solves itself. The way we can avoid this happening is we just calculate our chunks from the outside in. Okay, wait a second. So let's think about this a different way. This is horrible, right? Right now what I have is I have 2 priorities, right? First priority is what command type we're doing. Second priority is the distance of the chunk to the player. What if instead of starting from the chunk closest to the player when it comes to lighting, we start with the chunk that's farthest away from the player? Well, the chunk that's farthest away from the player is going to be a chunk border. So when he goes and he checks to the right of him, it's just going to return, I think, 0 by default. So then it just takes these light levels. Now, most of the time, you won't notice that these aren't correct because it'll be on the chunk border, right? The player should never be near the chunk border. That's the whole reason it's a border. It's the radius border. So then that means that all of these values will be correct by default. Then when we go to an interior chunk, which is in here, he will check all of these values. They will be correct. And then once he gets to here, there's a chance that these are incorrect. Wait a second. Yeah, because then we have the same problem, right? The same problem is, what if this light level is higher than this light level? Yeah, so this is a harder problem than I thought, right? I'm trying to think of what the best way to do this would be. maybe the best way to do this is like a flood fill. And so not necessarily doing a loop like, okay, how about this? Instead of thinking of it this way, we do the first pass, which just does this normally, right? The first pass just does internal blocks. It doesn't even worry about external chunks, right? So the first pass just updates whatever's inside of my chunk. So we just update all the sky level values inside of here, right? And then if we hit a block that's not a sky level, say we go down and then this is a block, then this one will no longer be a sky level. Then we just update all of these accordingly, right? And then, I don't know. This is a tough problem. Let's see. Do you guys have any suggestions for how we might be able to solve this in a different way? And how's it going, Ronan RTP? Hope you're doing all right. Okay, I'm just going to catch up on chat real quick. So, yeah, we're doing block level lighting, and right now we're running into a problem because of chunk borders, and I'm beginning to see why Minecraft chose 16 as the highest block light level that you can have. They did that for a reason. It's because turns out going across chunks is difficult when you're updating lighting. And that's because of the way it works just intuitively. So I'm trying to think, what if we just do flood fill for all of it? Basically, like we start at the top and then we pick one light source. That goes and updates all of the neighbors that need updating. I think this is the way we do it. Or we just pick, we'll pick the block on top of the player. So whatever chunk the player's in, we pick the center of that chunk. We take the top of that block and we start there. And then we flood fill from there. And if we flood fill from there, then by nature, it will become... It will update all chunks until it hits the border. Okay, so this is a flood fill algorithm. This is not something that you can really parallelize. Yeah, I don't think you can parallelize this because you have to start from one area and then you just have to go out. Can you parallelize a flood fill algorithm? I don't think you can. Okay, let's go back to the drawing screen. We'll talk about this one more time. So, going across chunk borders is bad because we have to sort of check and see if they've been updated, all that stuff, blah, blah, blah. It doesn't work out very well. So what we have to do is say the player's standing right here, right? He's in the middle of a chunk, right? And then the chunks kind of go out in a circular fashion. So if the chunk radius was 1, we would just have this, right? Okay, so we would just have like a circular shape of chunks which all surround the player. What we can do is we can select the center of the chunk that the player's in. We'll select the top block, and then we start from there. And we say, okay, update all the blocks to my left, my right, my bottom, everything. Check and see if they've been set for light level. If they haven't, then we're going to update them. And then what those guys do is they add to their queue all of their neighbors. They add to their cube all of their neighbors, so on and so forth. And it just goes on. And eventually it's going to hit a chunk border, and it's just going to go on and say, I need to set him. I need to set him. And so then they go into the chunk border automatically just because they need to until we get down to here. And then he'll say, I need to set him. He's outside of the border radius, so he just doesn't get updated at all. This is what we need to do. Because that way we will make sure that we never encounter an issue with going across chunk borders because we'll always be updating the correct light level first and then going from there. Okay, so I think this is what we need to do. So no parallelizing this. We just need to make sure we do this all at once. So let's go back to the main screen. And Langors, in this case, can't you parallelize each direction? You can't do that because, like, technically you need to make sure that when you queue them up, you do the neighbors first. That way, if one of those has the brightest, here, if we take a look at Minecraft's thing again, right? If we parallelize this to the right, say he started going faster and he was 13, 12, 11, 10, 9, 8, and he got down to here, and say this one hasn't gotten to here yet, then he would keep going 7, 6, 5, and then this guy would start overriding him, and yeah, it wouldn't be good because he wouldn't realize that this hasn't been set, and then he might get to here and this would be 5, and then he would get to here and they would see that each of each other has been done already, and then they would just stop. So yeah, that could be a problem. This is just a bad algorithm in itself. Flood fill just doesn't work very well because of things like this. So yeah. Okay. Ronin RTP, is the game working? Yes, it is mostly. So we're just trying to get lighting working. I can show you what we got right now for any of you who have joined since the beginning. So if we load this up, we just ran into a problem with the lighting. So it looks weird, first of all, because I don't have the lighting set properly, but you'll notice that when we hit a chunk border, it just stops updating properly. And so this is what we're trying to solve right now, which we can only solve using that flood fill algorithm that I just talked about, because that's just the best way to do this. So we will have to use that, and I'm still trying to think through how all of the details of this will work properly. Okay, so basically what we're going to do is up when we queue the lighting command, we only need to queue that once. So instead of queuing it immediately after we finish drawing everything, we'll queue it from the main thread. So we fill the block data. Instead of doing this, we will do... I think we'll just queue it from the main thread, and then we can just go ahead and queue all of these tessellate commands from the main thread as well. So we'll just do all that from the main thread. Queue the lighting calculation command, so we just need to move this off, which I guess makes more sense anyway, since we probably shouldn't be queuing from other commands. They should just be doing their own thing. Okay, so then if we go to the main thread where this gets started, which is somewhere down here. And since these commands are prioritized anyways, we shouldn't have to worry about like them getting done out of order. They should always get done in the correct order. Okay, so we get here. This is serialized. We don't care about that. Create. Okay, save. Get block, set block, remove block. I think it's check chunk radius is where these all get queued. Yes, okay. So when we check the chunk radius, we'll basically do all this. Okay, so we'll remove out of range chunks, that's fine. We retessellate edges. And then this is going to go ahead and queue the ones that need to be created. And after we queue all of the ones that need to be created, I'm trying to think of how the best way to do this would be, because we don't technically have one thing that starts it off. If I look at the init method, we have a few init methods. This doesn't really do anything, right? What I should probably do inside of here is say check chunk radius, but we need the player position to do that because, yeah, okay. So I guess we'll go into check chunk radius, and we'll have a flag in there to see if it's the first time that we're doing this. So we'll have a static Boolean in here. And this will be is first time equals true. And that will be the first time we hit this will be true. And then I'll set is first time equal to false here. Okay. And then what we can do is once we queue up all of our commands, we can say if it's the first time, make sure to queue all the tessellate commands and all the lighting. Well, I guess just the lighting command. So, and the lighting command. So what we'll do is we'll say we have this chunk manager queue create chunk, and then we'll have, let's look at how this works just so that I can get that command code. Yep, so we'll get all that. And then, where was I? Okay, here. And then we'll copy that, paste that there. So chunk coordinates is going to be whatever the player's chunk coordinates are. So this guy. Command type is fill block data. Command.block data, chunk free list, all that stuff, blah, blah, blah. And then we're going to queue the command, and the command is going to be not this. It's going to be calculate lighting. And I guess we should have like, well, I guess this is only going to be the first time, right? We only ever have to run this once. I'm trying to think of how this is going to work once we start loading in new stuff. And we're probably just going to have to do this. Okay, let's change up. Sorry. If I'm not making much sense right now, sorry too. It's because I'm trying to think out how this is going to work as I'm doing it, which is kind of weird. So instead of doing it this way, what I'm going to do is I'm going to say right now, if the player moves 16 blocks in any directions, we load in new chunks. So that's what this whole thing is. Let's see. It's somewhere in here. Oh, wait. I think the check chunk radius only ever gets called. Here, let's check this again. It should be in here somewhere. No? Check chunk radius. Okay, I guess this is getting called within the world. Check chunk radius. Okay, yeah. So we basically, oh, cool. So we do call this right after we initialize. So we can add in a flag here too. That says this is the first time, but we don't even need to do that because if we look into here where it gets called, we should see, yeah, okay. So we say last player load position. And then we basically check and see if the player's position, the distance from the last time we loaded new chunks to whatever the player's position now is greater than 16 by 16 radius, so like a chunk radius, just a single chunk, then we load things again. So this isn't getting run every frame. This is only getting run certain times. So that's good. That means that what we can do is we can just make sure to queue this up immediately after we do that, and we'll recalculate the lighting every time the player moves and we load in new chunks. That way it does the flood fill algorithm again and all new chunks get set appropriately. So with that in mind, now what we can do is we can say, give it the player's position and chunk coordinates. We want to calculate the commands. The block data, we give it the block data for whatever the player's position and chunk coordinates is. So I'm actually going to remove that because we're going to have to do something weird to figure out which block data to use. And we'll get rid of that. The sub chunks, we don't really need that, but I'll keep it there anyways. So just in case. And then what we also need to do is we need to make sure that we run tessellate on all of the new chunks as well. So when we do queue create chunk, we can just add that in up here. So we have fill block data, and then what we can do is wherever we queue the command, which is right here, we can say cmd.command type or .type equals command type tessellate. Okay, and then we'll just do chunk worker .queue command cmd. Okay, so that way we should get like a tessellation command queued up at the same time. And that means we shouldn't have to worry about anything. Let's see, just double checking this stuff. Okay, so that's all good. Okay, and that will run after everything's already been done, filling the block data, so we should be good there. With retessellate, I have to do the same thing, which is right here. So then we'll just add one more there. And when we're saving the chunks, that should be fine. Okay, so if I run this now, what should happen is basically the same thing, except only the chunk that the player's in will get its lighting updated. And we'll work on that in a minute. Let me catch up on the chat real quickly. AK Dev, that's sick, not gonna lie. I have no idea what you were talking about there, sorry. Langors, do one for x-axis and another for z. It shouldn't run into that problem, I think. Well, if we have... Yeah, you're right, actually, because if we're only flood filling from one point, because we're picking the single point, right? And then we're just flood filling left and right and down and up. So if we just pick one point and then we say, just start going, we can parallelize that. And he just goes left. And every time we have a left one in the queue, we just go left. That's a good idea. We'll look into that. First, let's see how it performs, because it might not even need to be parallelized. And if it performs fine, we can just go with it. Yeah, but I guess for now, you could just do it with one thread and worry about that later. Exactly. CGO Clan, can somebody answer this error? No free pools for block data. You ran out of memory. That's fine. I'm fixing, that's been fixed in some future updates, I believe. So I'll take a look at that at another point. But yeah. Langors, never mind. It could happen diagonally. Okay, you'll have to explain that too, because I think that shouldn't happen. But yeah, just one in the center. And then in that case, it should work. Yeah, exactly. And Voxverse, why is pool the only HPP file and others are H files? It's killing my OCD. Pool is HPP because it's a template file. And so in C++, the standard is like if you have a template file, since it contains C++ code inside of the header file, since by nature you have to have the C++ code there in order for it to generate that code, the standard is just to name that an HPP file. So yeah. So it shouldn't be anything like too bad, but yeah. Okay, we run into a problem immediately. What is this? Access violation. Oh, it's because I didn't set the block data. Whoops. Okay, let's remove this for now and just make sure I didn't break anything else, because this is all going to change anyways. So we'll just remove all of that. Man, who would have thought, right? Simple lighting algorithm is so complicated because of the way the world loads. Okay, so it looks like all the light levels are just getting set to, whatever they were loaded as. That's why these are all, yeah. So it's basically just loading the light levels into whatever we serialize. That's why they're all the same. If I break a block, it's just going to be 0 underneath. But I shouldn't have broken anything. And I'm going to look and see if I hit that error that you got. One thing you can check too, Mr. Hecker, CGO Clan, is I have this chunk RAM up here. If this gets close to its maximum, that means you're running out of memory. But if you're getting that error and you're not getting close to that maximum up there, I'm not sure why it would give you that error, because that's basically telling you how much you have left and how much you're using out of that total pool of memory. So you can see that I'm good and I'm not hitting that error or anything, and it's still loading all the new chunks. And this is what I wanted to check. So all the new chunks down here are loading and they don't have any light levels associated with them, which is why they're all dark. And then you'll notice that that will sort of settle down after we load new stuff in. So yeah. Okay, cool. So that's what I wanted to check. That's all good. Now we have to change this algorithm completely. So first of all, what I should do is this is not going to take block coordinates. This is going to be this, and I'm going to change the name of this function because it's kind of different. So flood fill light from chunk. Flood fill light from chunk. So we'll call it that. And then if we go into chunk manager.h, I think I have to, yep. Let's just remove that. Okay. So this is the chunk we're going to pick our center coordinate from, and we'll go from there. And if we go to calculate lighting right down here, we will change this to chunk flood fill light from chunk command dot block data, or no, I'm sorry, just command dot chunk coordinates. Now this is another thing too that's kind of hard, because as we're doing this, we kind of need these test late vertice commands to wait until we finish this, which is bad because it's like a synchronization point, right? It means that until the lighting gets finished calculating, we cannot start doing this, which just isn't that great. We'll see how it works right now. I have a feeling we're going to run into race issues because this will be trying to do its work while this is doing its work, and that's just not good. So we'll see what happens, and then we'll go from there. Okay, so let's go back to that function. If we can fill out the logic, that's the most important thing for now anyways. What did I call it? Flood fill light from chunk. So if we go down to here, what we can do is I have a function in here, which is, so we'll say chunk coordinates dot y. What we want to do is we basically want to say glm ivec3 local chunk pose. We'll say start position, and that's going to be whatever the center of a chunk is, right? So that would be glm ivec3 world chunk depth, because the x is the depth, over 2 world chunk width or height over, nope, this will be the top one because we want to start from the center on the x and z, but we want to start from the top of the world. So we'll do that -1, and then world chunk width over 2. Okay, so that's our start position. And then what we want to do is we just want to start flood filling from here. And I already have a function that sort of does that, but it's not very good because of the way it does it. So we'll have to modify that, and we can use it though. So what we can do then is we can just say update block light level. Okay, and it's expecting block data too, which isn't good. So I need to fix that as well. I'm trying to think of what the best way to do this would be. So I think I added a function to help us out with that. So we'll say block star block data equals chunk manager get block or get chunk, and this will get us the chunk from the world position, which is going to be our chunk coordinates, or actually our start position. So let's calculate that in world coordinates real quickly. glm vec3 world coords equals our chunk coordinates times 16 plus our start position. Correct? I think that's correct. Oh, and this is going to be, okay, so we have to do a glm vec3. This is going to be chunk coordinates dot x times 16, 0 chunk coordinates dot y times 16, because that's a 2-dimensional vector. Okay, which is just the x and z position of the chunk plus the start position, which is a glm vec3 dot x start position dot y start position dot z. Okay, so that's good. We should have, let me just move that to a new line. So we should have that in world coordinates, right? We just multiply by 16 and then we add whatever that guy is. Then we can say block star block data, which I was doing down there, get chunk. This takes in a world position, world coords. That should get us the appropriate chunk for this, the block data at least. Okay, so now we have the block data, and then what we can do is we can say update block light level, and that will update this block's light level. We'll pass it the data. We'll pass it our x, y, and z, which I believe are in world coordinates. That might be in, I should check that real quick. And we should make that explicit. Okay, no, these are local coordinates. So we should say local x, local y, and local z. So we'll do that. Okay. And I might need to forward declare this too, because I don't think this is forward declared right now. So let's go up there and forward declare that real quickly. Okay, so we got that forward declared. All good. Okay, so then back down here. Now we know it's local coordinates. So we have the local coordinates, which is just our start position. So start position dot x, start position dot y dot z. Okay, and then we pass it the chunk coordinates. So we pass it the chunk coordinates. Cool. So now this should recursively just start in flood fill, right? But we don't want to do this recursively. We want to do this iteratively because we kind of want to do like a specific order, and we want to queue up commands in the right order. Right now, what I'm going to do is I'm just going to use a std queue. I'll probably switch to like an actual array later on, just because it's probably better so that we're not allocating memory and stuff. But yeah, let me catch up on chat real quickly one more time. CGO Clan, deleting the world while the program is on and then clicking load world crashes the program. Yes, I would assume that would crash the program. Does it give you an error? Because I'm guessing it either gives you an error, but it might just crash because I'm not checking for that. So thanks for mentioning that. I will add in checks in the code just to make sure that doesn't happen. But I think it should fail an assertion. It should say something like, I don't know. Maybe it doesn't though. I don't know. Okay, so basically we're just gonna check if local x is greater than equal to 16 or it's less than 0. Local z is that or it's less than 0. And if that's so, then we have the wrong chunk here. So what this does is it goes and gets the correct chunk and then it calls the same function. We kind of have to change the way this works just by its very nature though, because yeah. So what I'm going to do is comment all this out for now, and then we'll see where we go from here. Okay. So let's comment that out. That's good. We'll start up here. So how is this going to work? Well, this is just like we're queuing up positions, and then we want to work on those positions as we queue them up. So now, since we're updating the block, the first block in the queue is going to be this block. This is still kind of important because if we get past a block that's out of bounds, we don't want to use that. So what I'm going to do is I'm just going to say, if this is true, we try and get the chunk for the one that they actually asked for, which would be this local x, and this local z, and this local y. So we'll do that. And then where's the local y, which is that. Okay, just to check these things. So basically, if somehow we got passed in a coordinate that's not actually local to this chunk, then we find the appropriate chunk, get that block data. If it doesn't exist, we don't do anything. If it does exist, then we go ahead and get new local coordinates, and then we set our local x to that, our y to that, and our z to that. Okay, cool. So this will basically just make sure that these are actually local to the chunk we're in, and then this makes sure that we actually have block data that's the appropriate chunk. So that's all good. And then if y is out of bounds, we just return. That's also good. We don't want to try and update something that's not in world height, so we just do that. So that's all good as well. So now we get to here. What's happening here now is we want to queue up our first block. Our first block is our local x, local y, local z. So we'll have a queue of GLM IVEC3s. And first in, first out will be fine here. We want to take in whatever was put in first and work on that, and then we'll take the next thing. So this is, I guess this is similar to like a tree traversal. If you were doing a breadth first tree traversal, this is sort of how that is. And CGO clan, I have 12K channel points. Nice. Okay, so we'll say this is our light updates. And thank you, Blood Moon Phoenix, for following. Nice to see you. So these are our blocks to update. And this is going to be just a normal queue at first. So we'll do that. And we want to queue up our first block, which is our local x, local y, local z. So we'll just do a GLM IVEC3. That's all good. And I don't know why I expect that to be a function. Okay, cool. So that's all good. We have that first block, and now what we want to do is we just want to work on the queue until it's empty. So while this queue is not empty, we continue to go. So we'll say, let's see, while blocks to update, dot empty. Well, it's not empty. Continue to work on it. I just thought of something else too that I have to fix because this could potentially break. Let's go back to where we call this, which is not there or there. There. No, not there. Yeah? No. It's, oh wait, I'm looking for another thing. It's flood chunk. So where do we call this? Flood, fill light from chunk. Yeah, let's look for that one. Okay, here we go. This could potentially break, right? Why could this break? Well, if this start position is pointing to a block that's not an air block, this would not work properly. So we have to find the first block in this chunk that's an air block. And what if this chunk is completely filled? Then we're just kind of screwed. So maybe we'll, I don't know. This is a bad thing too. I guess what we'll do is we'll just continue to flood fill until we fill all of the blocks, whether they're air blocks or not. And if they're not an air block, then it just makes it easier. We'll do that for now. I don't like that idea because then we're doing a lot of unnecessary work. But until I can come up with something better, that's how it's going to work. Okay, so let's just go back to this algorithm and we should be fine. So we don't care if it's an air block or not. We're going to be working on this block no matter what. Let's go ahead. We need this code now. So basically what we're going to do is grab this code and paste it here. And then we'll just kind of go from here. Okay, so let me uncomment all this out now. Okay, so while the queue is not empty, what we're going to do is we're going to get the block from the queue, which is whatever this x, y, z are. So we'll say int x equals, well, first of all, I guess we'll say glum ivec3 block to update equals the queue, which is blocks to update dot front, and then we'll pop that. We probably want to pop this after we finish working with it too, because yeah, after we finish, but before we start working on the next one, because otherwise we could run into problems where it's like it tries to update this twice. Possibly. I don't know. We need some way to tell like if a block's been updated too. That way we don't start re-updating blocks that have already been updated. So I'll have to come up with some way to do that too. Okay. So let's just focus on this for now though. If the 32-bit is set, this is a sky block. Okay. So we basically say x, y, z, int x equals block to update dot x, int y equals block to update dot y, and dot z. Okay, so if the 32-bit is set, this is a sky block in the block above it. So we just set it to a sky block, right? Which is what we're doing here. If block data array expansion dot light level. So we don't really care about that. What I'm going to do is this for now. So we'll do int array expansion equals to 1D array x, y, z. Okay, so we set it. If it's a sky block, we set it to be a sky block. Otherwise, we do this whole maximum neighbor minus 1 thing, right? So we take the brightest neighbor and we subtract 1 from that, and then we clamp it to 0 if we need to. That's all good. Okay, so now this block's been updated. We are good there. And we don't care about this because I'm going to have to do something different for that. Okay, so then we set the light level. That's all good. Now we have to queue up the neighbors. We also have to figure out a way. So let's see. If we look at our blocks, we have 16 bits for the light color. What is 32? That's 2, 4, 8, 16, 32. That's bit 5. So we're using bit 5 to determine whether it's a sky block. We'll use bit 6 to determine whether the block needs a light update. So we shall say, I'm trying to think of what the best way to do this would be. So we have all the neighbors here too. We're going to have to get all the neighbors no matter what. So maybe I should have this outside of here. So we're going to put all of this right here. So these are all the neighbors that could possibly be touching this block. Okay, so that's all good. And now we queue up new blocks. So we'll say if top block neighbor. Oh, wait, first of all, we also have to say block data array expansion dot light level equals or equals, and then we're going to do 64, which is the next bit. Okay. So now we've set this block to like it's updated. We don't have to update this anymore. And what we'll do is we'll say if top neighbor dot light level and 64. So if it's not been updated, then we'll add it to the queue. So we'll say blocks to update dot queue or push. And I guess glm ivec3, that's the top neighbor. How do we get that XYZ? Okay, so we just got this X, Y plus 1Z. And I should probably do this as get block internal because there's not a guarantee that this will be right. So let's change that to that. That we're good. Okay, so it's just X, Y plus 1Z is the top neighbor. So we'll just do that. Okay, so that's fine. Trying to think this through and everything. Okay, that should be fine. Cool. So we push that if we need to, and then we'll just do the rest of them. So if not bottom neighbor dot light level, then we'll push that guy too. And then we'll do the next one, left neighbor. What did I do there? Totally messed that up somehow. Too many parentheses? Yeah. This should have a parenthesis there. Okay. We'll do that. And then we'll just say blocks to update dot push. This is the left neighbor, so X, Y, Z minus 1. We'll do right neighbor. Z plus 1. We'll do front neighbor. That's going to be X plus 1. And I need to spell neighbor right. Okay, cool. And then we'll do back neighbor. So I knew block lighting was going to be a pain, but I didn't know how much of a pain it was going to be. Right? Okay, cool. So then we push all the blocks. Then we pop our block. We're good. Everything's good. We're fine. And we don't have to actually worry about that yet. So what I'm going to do is I'm going to actually pop that immediately. Because what we do is we set it to... Yeah, we set it to updated. So set this block as light level updated. Okay, and then this should just go through and basically find the rest of them. What we do have one thing to worry about, which is if the X, Y, or Z, when we hit this, if either of these are negative, X or Z, or if Y is out of bounds, then we basically just don't want to do this. So if Y is greater than or equal to 256, or Y is less than 0, then what we can do is we can just say continue. That's fine. And if X and Z are out of bounds, then we basically just need to get the next chunk. So we'll say if X is less than 0, or X is greater than or equal to 16, or Z is less than 0, or Z is greater than or equal to 16, we basically need to do the same thing we did up here, which was all of this stuff. So we'll do that. Copy that, paste that. We should probably turn this into a function. If not block data, we'll continue. So if this is out of bounds, we just skip that. Otherwise, we continue as we were. And then this will be X, Y, and Z. And then this will be that. Nope, doesn't work right. Okay, cool. So we're good. CGO Clan, hey Gabe, can you check your DM once, Discord? I'll check it after stream. Thank you, though. If it's a bug, you can mention it in the chat and I'll think about whether we have time or not to check it out right now. So this should be a flood fill algorithm. Let's see if it works the way we want it to work. I have a feeling we're going to run into problems because of threads doing stuff at the same time. And immediately we can see that it did not work right here, because this should have been updated if it was actually doing that. Actually, what we can see too is we're taking up a bunch of memory. So this is what I was afraid of too. Yeah, it's going to take up a bunch of memory because of that queue we're using. Let's see how far up that goes. Yep, just going to keep going up. Okay, so we hit 4 gigabytes. Nope, we hit more too. And this isn't even good anyways, because it's not even going to be, yeah, okay. So we need to rethink the way that we do this, which is really annoying. We technically could do it recursively, but we'll run into the same problem just with the stack trace instead. That's technically not a memory leak too, because it will be cleaned up at the end of this. It's just that we're hitting this. So this is the problem with the flood fill algorithm, which is if we just keep going forever, it's not good. So we do need to stop. We can't just add blocks that we want to. We need to say if the top neighbor's light level isn't set and the top neighbor is an error block is what we need to check. So we'll say, and that is an error block. So we'll say block map error block. So we'll do that. Whoops. And then we will also do that for all of these. Let's just paste that first. So same thing there, same thing there, same thing there, and same thing there. And we also need to check one more thing just to make sure we're not updating unnecessary blocks, and top neighbor dot light level, or I guess our light level. What we can do here is we can say if our light level and 31. So if our light level is 0, we don't need to keep updating blocks around us because they're just going to be 0 too. So if that's 0, then we'll stop. So we'll just hit continue. Okay. I guess we could just wrap that. We'll just say if not, and then we'll do this. And then we'll do that. Okay, cool. And I have that set up wrong. Okay, so if that's not 0, then we will update our neighbors if needed. Okay, let's see how this runs. Should stop way faster because we'll hit the solid blocks and stuff pretty fast. Okay, this is definitely not doing the right stuff. What's happening here is we're hitting texture coordinates that are out of bound. I think I probably got an ID that's set the wrong way. So yeah, it's modifying block IDs, which is not good. So why is this modifying block IDs? It shouldn't be doing that. Let's comment. Okay, so this is light level. Light level. Yeah, that's really weird. It shouldn't be modifying any sort of block ID. Is it this equals operator? Nope, that's just returning whether the blocks are equal. That shouldn't do anything. Okay. Yeah, nice buildings, I know, right? Man, this block updating is much more of a pain than I thought it would be. I almost wish we could just not do it. Here, you know what we'll do? I'm going to go to YouTube real quickly because I know JDH made a video on this, and I'm curious to see what he did. Minecraft. So, adding infinite build height and colored lights to my game. I'm assuming this is where he would have talked about lighting. Yeah, let's check it out. And if you guys hear, I'm going to mute my mic real quick just so that I'm not getting double audio here.
Welcome back to my channel. This is a relatively brief update video on the state of my Minecraft clone, which I made in 2 days after making some more substantial updates to the engine. Go check out my previous video if you haven't seen it, since it lays the groundwork for most of this video. So to jump right into the updates, one of the first things the codebase desperately needed was refactoring and cleanup everywhere. because I only spent a really basic world generator and placed some blocks to make sure that nothing was too broken. Source. This lighting. Lighting in Minecraft works by giving every transparent block a light intensity value between 0 and 15 and having neighboring solid blocks use this value to determine the brightness of their faces. Basic implementation required some minor tweaks to the rendering and meshing code, and I got some good results really quickly. Once I had the graphics groundwork in for light intensity, I moved on to propagation. For somewhat realistic light attenuation, Minecraft uses a system where light propagates from one block to another by losing one unit of intensity with each block of distance from the original light source. This quick animation gives a simple example of how that works. If we only allow light to propagate through transparent blocks, then we get some basic shading too. This is easy enough to implement using some basic cues and looks pretty nice.
Okay, yeah, so it looks like he's not going to give very useful information there. I should have expected that. So, I think what the problem we're having here is this is going to be good for when we do like single block updates, right? This is like updating a single block. This will work pretty good. What it's not going to work good for is when we have to update the chunks at the first time. And so this is our problem too, is like figuring out how to set all of our blocks the first time is pretty hard. I may take a break in a minute and just think about this for a few minutes just to see if I can come up with something better. Yeah, I think that's probably a good idea. Okay, I'm going to take a break for like 10, 15 minutes and I'll see if I can come up with something better. And then I'll come back to this and we will see if we can figure this out. Okay, so I'll see you guys in just a little bit. Okay, I am back, and I think I've got it. So we should be good. I know that was quick, but sometimes you just need a minute to like really think. And CGL Clan, I don't think OpenGL has a built-in lighting system. Don't know where you might have read that, but I don't believe it's got anything like that. So, but let's go to the drawing screen real quickly. So, I'm kind of going back to the original idea, right? What's the problem we're having right now? The problem we're having is borders. Borders need to be update after the chunk finishes updating. So what we can do is right now, whoops, I'm going to erase that. We have our command type, which is fill block data, which gets all of our block values. And then we have calculate lighting, which calculates all the lighting. What we can do then is we can say like, I'll just call that calculate lights. We can have calculate borders, okay? And you may be like, okay, how is this going to help us? Well, what we're going to do is when we calculate the lights, what we can do is we can set all transparent blocks on the borders to basically just whatever they would be, right? So we do this normally. We set these to whatever they would be based on the values. We don't even worry about the chunks to our left and our right and stuff. We just take it based off the values inside. And then inside the calculate border step, what we do is we say, hey, check to the right now. And this should only run after all the chunks have finished calculating their lighting, right? So then after they've all finished calculating their lighting, we can say, check to the right. Is this brighter than what I'm at? If it's brighter, only then do we start running the update here. But if it's not, we don't worry about it, right? Because this wouldn't even change. Nothing inside would change. If it is brighter, then we go to our flood fill algorithm, except we only flood fill inside. And this should solve all of our problems because now we're not going to be using an insane amount of memory for our queues. We're only be flood filling a few blocks or so. We should not go outside the edges. The only problem that could happen as we're flood filling is like we flood fill all the way to the left, like I said, and we cross a chunk border and then we start doing this. And that's a problem for the future. One really easy thing I could do is just in my game, I could have it set to 32. And then go from there. Maybe for the Minecraft clone that we're doing now, we'll leave it to 16 as the highest light level, just so that we don't run into this issue. And then in my game, what I would do is I would just have a 32 by 32 radius for chunks, which should solve all this. So I think this is our approach, and this should work good. So we can go ahead and try and implement this. This is also why I don't just go off the cuff when I'm doing my tutorial videos and I have it pre-coded, because if you're just trying to figure stuff out on the fly, it's pretty hard. So yeah. Oh, so the built-in lighting is okay, so it's legacy. Yeah, legacy OpenGL maybe. But even if it has, I don't think it would allow to do something specific as block lighting. Yeah. So, okay, so let's go up to our command type. Because the first thing we need to do is say add a new command type. So we have calculate lighting, and then we have calculate chunk border lighting. Okay, so this will go ahead and go through all those and update anything that needs to be updated. So calculate lighting is going to work the way it did before with one minor difference. And hopefully I still have that, but I think I might have removed it. So we might have to go back and GitHub and get that back. So let's see. Somewhere down here, and I don't think I actually added that to GitHub too, which is a bad thing. So we might not even have that. Yeah, because I changed the name of it and everything, didn't I? Yeah, I called that flood fill light, which we still sort of need, but we also need calculate lighting now. So this will take in block star, I think is what we did. Block data, and then it will take in a const glm ivec2 chunk coordinates. And I should have saved this, but I didn't. So I think I might have to redo it. Flood, fill, lighting, but we have most of the code still there. So we should be good. Yeah, I removed it. That was stupid. Okay. Anyways, it should be fine. So we do this. What we're going to be doing is basically what we had in here. Let's go down there. I wanted to go back because I went a little bit too far. Yeah, it's basically this stuff, right? We basically just want to do this. So let's grab all of this. Yeah, okay, I'm just gonna grab all of that. And then what we're gonna do inside of calculate. So let me find that. Calculate. No, I don't want to find in selection. Come on, Visual Studio. Okay. Calculate light. Wherever that is. There we go. Okay. So what I want to do is I want to say for int y equals world chunk height -1 until y is greater than or equal to 0, y minus. For int, I think it's z is the next one, x and then z. Okay. X equals 0 until x is less than world chunk depth x ++, and then for int z equals 0 until z is less than world chunk width z ++. Okay, cool. So this way we can parallelize stuff too pretty easily, which is good. Let me just make sure that's all right. That's all right. Cool. And then we'll paste that code we had. And we'll have to modify this a little bit. CGO Clan. Well, even if we can't do block lighting, real lighting that comes in shaders is cool. It's projects the light rays from the point of the sun. Minecraft does lend itself good to like ray tracing and stuff, but I don't know how to do ray tracing right now. So I'd rather, and this is a Minecraft clone, so I want to be able to tell people how to do a Minecraft clone if that's what they're looking for. But yeah, so what we're going to do is not this stuff. We've got X, Y, Z. If Y is greater than or equal to 256, we shouldn't have to worry about that because we're going here, right? We're fine. Okay. If X is less than 0 or X, we shouldn't have to worry about this either because we're doing this. So that's fine. Okay. Okay. And then what we're going to do here is something a little bit different. Instead of doing it this way, because what get block internal does is if we take a look at that, yeah, what this does is it basically checks to see if it's inbounds of the chunk that we pass it. If it's not, then it goes and it looks for the correct chunk to look for. We don't really want to do that because that requires synchronization of the threads and stuff, which isn't good. So instead of doing that, what I'm going to do, wherever that was, yeah, okay, is I'm going to check and see if it's inbounds. If any of the neighbors is out of bounds, we'll just give it 0, which means that shouldn't be taken into account. So what we'll do is we'll say if y + 1 is greater than or equal to 256, then we'll do 0. Otherwise, we will do block data to 1D array, and we'll pass it that, and we will do that, and we're good. Okay. Which should give us a block, right? Right? Oh, this just needs to be, so we'll say block map, null block. Okay, so that's fine. The null block has a light level of 0 automatically. Yeah, it's just a bunch of zeros. So that shouldn't affect it at all. Cool. Okay, so then we do the same thing for left neighbor. And it's not air block too, so that's also good. So when we do the light level, it'll just default to 0. Cool. So then we do the same thing here. For left neighbor, we're doing Z -1, and I'm going to move this one actually so that we kind of do this in the right order. This is something that should be rolled up into a loop too, which we'll have to do eventually. Okay, so Y -1. If Y -1 is less than 0, we'll give it block map null block. Otherwise, we'll do, I'm doing the wrong thing there. Okay, so right here, if Y -1 is less than 0, we'll do block map null block. Otherwise, we'll do block data to 1D array, that, and we're good. Okay, cool. And then we do the same thing here. Voxelrus, LMAO, shootouts. I meant should. Wait, block lighting is good, taking into account the difficulty implementing ray tracing. Yeah. SE Woods, you're back. Is Minecraft done yet? Not quite. Okay, so let's keep going here. So if this is left block, so if X or Z -1 is less than 0, we'll do block map null block. Otherwise, we will do block data. And then this is 1D array. And we'll do that. We're good. Right neighbor, z plus 1. If that's greater than or equal to 16, we'll do null block. Otherwise, we'll do this. This should speed it up quite a bit too anyway. So I'm happy with the solution. Hopefully it works. And we'll do this. Okay, and then the right neighbor. So, no, front neighbor now. Okay, so if x plus 1 is greater than or equal to 16, we'll do null block. Otherwise, we'll do that, and that. Okay. And finally, for the back block, we'll do back neighbor, which is x minus 1 is less than 0. We'll do the null block. Otherwise, we'll do that. And I think I didn't do the 1D array in that last one. And the last two. Yeah, that should be 1D array. And so should that. Okay, cool. So that's all good. We're basically just going to go through. We don't really care about coordinates that much. We check if it's a sky block, do all that jazz, right? We're doing all the same stuff here. We're not even going to care about chunk borders right now. So if we do this as it is, we should be fine. After I fix that command type, which was, what did we call that? Flood. Yeah, okay, so let's fix this first of all. So this will say chunk, and then this will say, what would we call that? Calculate lighting. Yeah, okay. So we'll pass it the block data, which is command.block data, and we'll pass it the chunk coordinates, which is command.chunk coordinates. And what we'll do is we'll do the same thing we did here. And now these commands are going to kind of propagate again, because that's the best way to do it. Okay, so this will say command.type equals command type, calculate lighting. And then we'll say q command, and then we'll say, let me just make sure I'm doing this right too, because I don't want to forget something and then have this not work. I have it pulled up here. So let's go to Minecraft source chunk manager, and then let's just check and see how this works. Yeah, okay, so we just do this. Let's just copy that. So except instead of queuing tessellation, we're going to do command type dot calculate lighting. So that command does that. This does, technically it's going to do the calculate borders, but we're going to worry about that in a minute. So we'll do tessellate vertices for now. And that should be good. And then I'm going to have to go where we queue this stuff up originally, the check chunk radius, because I modified that too. And we're basically going to have to, yeah, stop doing this thing again. So I'll remove that. Okay, we should be good. And I believe that should be good. So what we should get is basically the same thing we had before. Let's check and see if it works, and except a little bit better. And let me catch up real quickly. Okay, so if we go ahead and run this, no, it's breaking. Okay, what am I doing? So I must be doing some other stuff still, somehow. Let's see. So this check chunk radius, what is, oh, I think I modified this too. Q create chunk. So, oh, cool. Thank you, Kearney401, for following. Good to see you. Yeah, okay, so I'm queuing this stuff up too. That's not good. We shouldn't be doing that. So let's get rid of that. And I think I added that down here too. Yeah, let's get rid of those. And let's go back to this, and we should be good. So now if we do this again. No, it's still not good. So I'm still doing something really weird. It looks like we're tessellating those blocks when we shouldn't be. That's what's happening. I'm going to close that before it saves all that stuff. Okay, and the sun is getting in my eyes. Okay, so Am I queuing this twice? Is that what's wrong? No, so that queues that. That's fine. This says queue fill block data. That's fine. Yep, okay. Let's look for queue commands. What do I call that? Yeah, queue command. Let's see, where am I queuing commands? Okay, so this is just that one. That's fine. This is save block data. That's fine. So these are retessellation. Okay, so that's fine as well. I believe. What is this? This is retessellate chunk. Okay, yeah, this is fine. That's fine. Okay, so then when we do this, okay, so we say fill block data, then what we do is we say calculate lighting. We queue that up, that's fine. And then calculate lighting queues up tessellation. And then that should be good. Cool, so I think we should be fine here. Yeah, okay, that's fine. Yep, okay. So, oh, maybe I just saved bad data. I did this before. I was like looking for where my code was broken, and it turns out my code wasn't broken before. I had just ended up serializing bad data. So let's create a new world real quick. And we'll see if that works. Essie Woods, Gabe, do you use Trello or similar applications? Yeah, so that was just bad data. To plan the different steps you should implement into the game engine. I saw once that Thin Matrix used Trello. I've tried using Trello in the past. It's just, I can't follow it very good. I don't know. It just doesn't end up working well for me. What I typically do is I'll do something like what I did for this, which is I put a bunch of to-dos where I will see them. So like this is right in the README, and then I cross stuff out as I get it done. That way it's very visible and I just have it. Typically, like if I'm at work or something, I'll put it in my code, which means I will see it directly, and that's very good as well. So yeah, that's usually what I do. Something weird is happening here though. We are not updating the block lighting correctly, looks like. So I probably just have to fix our calculate lighting. I probably missed something here. So if y plus 1 is greater than or equal to that, we just give it the null block. Otherwise, we give it what the actual block is. That's fine. Yep. So all that stuff should be fine. And then we say if top neighbor, and I can get rid of these equals the IDs because I have that overloaded. Bottom neighbor. Oh yeah, okay, cool. So looks like I just had that in one place. Okay, so I think all those are right. So is skyblock equals that. Oh, I forgot. Okay, yeah, if it's a skyblock or y equals world chunk height -1, and yeah, so this is the only thing. And this is an air block. So block data array expansion equals block map air block. Okay. So I think that should fix our problem that we were having. Okay. So, and then I'm going to do a test because within a chunk, our lighting should work as long as it's, okay, nope, it's still not working. So I messed something else up. What did I mess up now? Yeah. So if it's a skyblock or if we're on world chunk height -1 and the current block is an air block, yeah, that's all good sounding, right? And we start from world chunk height -1. Then we set the light level to that, which is correct. Otherwise, we take it to the maximum of all of our neighbors, -1, 0. I guess technically this should be within the skyblock because this is telling whether it's a skyblock. So, or that. But yeah, still should work though. So if the top neighbor is a skyblock, that means this is a skyblock. Or if we're at the top of the world and we are an air block, then that means we should be a skyblock. Do we ever hit this? I should probably check that. Let's put a breakpoint in there, see if we hit that. Up until now, you just use OneNote. Yeah, I say whatever works the best for you, use it, right? Because that's typically the best thing to use. Okay, yeah, so we are hitting this. And I'm assuming we're hitting it multiple times. But it's not propagating downwards, it doesn't look like. Let's see. Is there something else I'm missing? So top neighbor. What's top neighbor doing? Fy plus 1 is greater than or equal to 256. World chunk height is 256. So we start at 255. That's fine. We're definitely hitting this too. So then on the next Y level, we would be at 254. So that means that this should not hit. So it should give us whatever this is, which would be 255. And since we just set the previous block to be 32, yeah, let's hit a breakpoint in here again, because I got to check this out a little bit closer. Okay, so we hit this. Y is 255. That's cool. What we want to do is we want to break on the next Y coordinate. So let's say continue to here. I think we can do that, yeah. Okay, so now Y is 255. Oh, it's because I have this breakpoint here. Let's get rid of that. So if I say continue to here, yes. Okay, cool. Now Y is 254. Okay, so we do all this stuff. Okay, so top neighbor light is 31. It should be 63. We should have set it to that, yeah. Oh, is it? Okay, wait. Yeah, so that's fine. Oh, I see what's happening here now. Because when we do this, yeah. Okay, I got this. So what we should do is, wait, no, yeah. This should be 63. Did I do something weird? I've got to redo this now because I have no idea what I just did there. Okay, so let's hit the breakpoint in there again. True definition of coding. Get sidetracked a trillion times and never finish your project. Come back to it after 2 years. Yeah, that happens. It's hard to finish things. Langor is not remember a single thing that you did and just start it all over again for no reason. I may have done that a few times too. Okay, so light level is definitely 63 after we hit that point. That's good. Let's get rid of that. Continue to here. Y is now 254. So our top neighbor, okay, yep. So the top neighbor's light level is 63. So that's good. That means that if we did, like if we said top neighbor dot light level and 32, we get 32, which is a non-zero value. So that should give us true. Cool. So once we go down to here, that is 63. That's good. So this should be true. It is true. Okay, cool. So then this light level is 63. Okay. So that's working correctly. Are we just never hitting this? Maybe. Even if we never hit that, that should be fine. Yeah, so we never hit that, which makes sense, but that should be fine. Is it MI generate render data? I guess I must be doing something wrong. So this is where I actually get the light levels and stuff. So what we do here is we say, yep, light level and 31. Okay, so that all makes sense. If we hit a breakpoint in here, we should see that this would be like some high value. It should be 31 or whatever, right? So if we do that, yep, that's 31. Okay, so that's all working properly. What is going on then? Is my shader code messed up? Oh, I know what it is. It's because I'm not setting the light color. Yeah, that makes sense. So then what we need to do as well is we say block data array expansion dot light color equals, and then let's go ahead and grab where we set color somewhere else, which is, let's look for light color. Not that, Maybe that? I don't know. I think somewhere else. Right here. No. Okay, that's the one I was just about to do. Let's go back down. It's going to be basically the opposite of this. So let's grab this. Okay, go back up here. Okay, so we need to set the light color. So this is going to be, we want to do 7, shifted left, and then we do like basically whatever those shifts were, and then we're going to do all that stuff. So we'll do that. And then we do and with that stuff. Okay. So I think that should be right, right? So we shift left 0, and with that, shift left 3. Yep. Looks good. Am I missing a parenthesis? Oh, this should be, so this is a color. Oh, I just need to get rid of the IVEC 3 there. Okay. So that's all good. Okay, so now we have the light color being set to. Okay, now we should see what we would normally see. So it looked like the light levels were all good. We just didn't have a color associated with the light. Okay, and I set the color very wrong there because we're getting red. But we are getting a light level set, so that's good. I thought 7 was the highest we could get for our light color. Pretty sure. I'm trying to think. And if we do 7, 7, 7, that would be white. Let's try 6 and see what happens. Let's see. S.E. Woods. I have a good programming question. Does broccoli and cauliflower soup sound good? That does. Yeah. Just had some. As long as you add a lot of cheese to it, it'll be good, right? Okay, so this is still like giving us a reddish tint, which is kind of weird. I can't remember what I did before this too. Let's go to GitHub, see if I have an example on here. So let's go into this source, world, this thing. Okay. Okay, yeah, I think I do have an example somewhere in here. Yeah, okay. This is exactly what I'm doing. I think I had this right. Maybe I have it wrong in the code or something. Did that change at all? No, that didn't change at all. Oh, I wasn't ORing it together. Okay, that's okay. That's why it was red, because we were only getting the red value. Cool, so now if we do this, we should get the appropriate thing for one chunk at least, hopefully. Okay, and we do. Cool. So what I'm going to do now is I'm going to go ahead and dig down, and if we stay within one chunk border and we reload this, we should see that it updates appropriately for these values. So let's go ahead and just dig down. And if it works for one chunk, then once we start adding the flood fill for chunk borders, we should have it working for all chunks. So if we just keep going down and then we reload this afterwards, we should be good. And the reason I'm going down in a spiral is just that we stay within the chunk, and it should update all of the blocks appropriately. Okay, I think that's far enough. Let's go ahead and save that, and we'll see what happens. How long am I streaming today? As long as it takes to get this stupid lighting working. So hopefully not much longer. I wanted to get cube maps done today, and I'll probably do that in my off time. I was hoping we would have this done pretty soon, though. Let me just break that block, too, so we can get out. Okay, so does it get darker as we go down? It does not look like it. So we have a flaw in our lighting algorithm. This is good. We're learning stuff. And I think the flaw is we're just checking to see if the light level above us is a skylight. Which means... Okay. So what that means is that this should be a skylight. This should be a skylight. This should be a skylight, right? All three of those. But then this one will not be a skylight. So it should take its brightest neighbor, which would be this one, -1. So that should be light level 14 or 30. Then this one would take this light level, right? And this light level. This one would also be 14. And then this one would take this light level and this light level. So this one would end up being 13. So then it should start degrading from there, right? Unless what is happening is this is somehow getting set as a light, as a skylight. So let's check and make sure that this is correct. So, so a block is a sky block if its top neighbor is a sky block. Yeah. Or if it's at the top of the world and it is a sky block. Oh, and we also have to make sure that it's an air block. That's what's happening. So we also need to go into here and say, and it's an air block. Okay, there we go. So if its top neighbor's a light, is a sky block, and this block is an air block. Otherwise, it doesn't matter. So let's do that. And now we should see that it updates appropriately. And I think it does. Look, you can see, so it gets a little bit darker on that block. You can sort of see the gradient shift. And then it should get a little bit darker here. And then if we keep going down, yeah, you can see that these blocks are definitely getting darker. Yep. We should eventually hit 0 though. Let's see if we keep going down. Does it? If we go down like 32 blocks, it should get to like this color, I think. So let's go and see if we can do that. I think if we actually just dig straight down too, it should do the same thing, because then the brightest block is going to be the block above it. So let's just dig straight down for a while. And we'll see if this works. Okay, so now let's see what we get. And let me just catch up. You prefer roguelikes. Oh, you guys are talking about some. Yep. Are the chat Minecraft players themselves? Yes. I haven't actually played Minecraft in quite a while too, which I guess is kind of funny. Mainly because I don't have time to play games at all. I feel like I'm usually working or coding or doing other stuff, but it's all good. Okay, so it's getting darker, getting darker. It looked like it got lighter here though. Okay, so that's definitely darker. This one is lighter than this one though, is what it looks like. That might just be because of the direction of its face. Okay, yeah, and then this is where we hit 0. Okay, cool. So we are definitely darkening as we go down. And then we hit 0 here, which means that it does that whole thing. Yep. Cool. So that means that this is working. We just need to adjust our algorithm, which like colors it. And I think that source I had. So let's get that working too, so that it actually looks good. Okay, there we go. So this source had something here. So yeah, so he said you do like the base color, and then he said the color value would be like power. Yeah, so let's just try this in our shader. And then the new color is the colors value. So this would be like the texture. Oh, color value, color value, color value 1. Let's copy that. We'll see if this works. So let's go into our shader code real quickly. And we do it right here is where we sort of do all this stuff. Okay, so we say our base light color, and then our color light value is this. Except what we're going to do is over 32, because we have that many, plus the base color. Okay, and then what we get is the final vec4 light color value, or I guess the light color is just the color value or color light value with 1 times, and then we're going to give it the light color. So f light color and 1. Okay. So then if we do that and we go down here, so what does he say then too after that, just in case? So he says, basically I'm taking light value from 0 to 1 to the power 1.4. This gives me a slightly darks on the linear function. Ensure that your value never goes about 1 and all that. Then in my shader, I get the fragment color to the texture and multiply that by the lighting color above. Okay, so then he's saying, and then what we would do is we would get whatever our color is, which is this, and then we would multiply that by our light color. Okay, so we do that. What is this doing? This is mixing the fog. So the fog, I think we would multiply all these together. We'll see what happens. We'll try that and see if this looks good. Okay. How's it going, Ike? I hope you're doing all right. I have been working on block lighting for like a million hours. Okay. Undefined variable light. Let's see. What did I do here? This should be whatever the light is, which I have somewhere in here. Let's see. Where is that? I think it was somewhere near. Okay, light level. So this should be F light level. And we need to do that as a float. Okay. And we can do that. And I think that should be fine. Okay, cool. So that should all be good. Let's see if our shader compiles now. Wait, did I fix this too? Yeah, this should be times. Whoops, times that. Okay, cool. So let's see if this works. And we get better shadows and stuff. I have another error. Okay, too little data in type constructor. Oh, I have that math thing in there too. So, whoops. This should just be power. Okay, there we go. Now we should be good, I believe. Okay. Nope, another error. Okay, unexpected semicolon. No, it still doesn't like too little data in type constructor. Did I have another thing in there? Okay, so base light color. Oh, this should be that. Color light value is float F light value over 32. How does power work? Let's look that up real quickly. Okay, so power, we do x, yeah, x to the power of y, which is what we're doing here. X to the power of y. Yeah, that's fine. That's fine. That should be fine, I believe. I think that should just do, we might have to do like color like that, and then same thing here. Don't think that matters, but I'll do it just in case. Okay, let's see if that's what we needed. Nope, it's not. Okay. Am I missing a parenthesis or something stupid like that? I think I am. Wait, no. Okay, that's fine. That's also fine. That's fine. Which line is it saying? 71. You gotta check the chat real quick. Wait, line 168, missing parenthesis. Thank you. Okay, thank you. That's what I was missing. Get rid of that. I don't know why I had that in the first place. Is that right? That's all right. Thank you. Okay. Should be good now. Langors, thank you again. Okay, so if we do this now. No, I have something else wrong. Too much data in type constructor. Too much data in type constructor. This is 1, 2, 3, 4 times 1, 2, 3, 4. That should be fine. Maybe this should be 1.0. Vec4. Mix that. What's the result? Result is Vec3. So mix that fog color is a vec4. D is a float times light color, which is a vec4, times F color, which is a vec3, and then we turn it into a vec4. Yeah, I think that's all good. Was it because of this? Let's see if that works now. I'm gonna check the chat again, just in case. No? Okay, it's something else. Too much data in type constructor. Wait, oh, in type constructor. So that's a float. That should be fine. Vec4, that takes in 1, 2, 3 floats, and then 4. That should be fine too. Wait, what's F light color? Oh, I think F light color is a vec3. So that's where we're going wrong now. Okay. Now we should be good. Fingers crossed. And it'll all look better too, hopefully. Yeah, F light color is a vector 3. Thank you, Voxel Riffs. Okay, there we go. So now this is working right. This is all a bit dark. So we might need to brighten it up more. Does it get darker as we go down? Oh, and it does get darker as we go down. That is good. I think it does. I can't tell because these faces are like light and then those ones are dark. Okay, and then it just gets really dark right here. That's good. I don't know if you guys can even see anything too because it gets pretty dark. Let's adjust our shader a little bit because don't quite like how dark it's getting. Okay, so we do the fog color mixed. So we get how much of the fog color contributes. That's fine. The fog color is just this, and then the result is our diffuse plus our ambient. Okay, so this is what we should probably change now because we're no longer going to be using diffuse or ambient light or anything. So we should be just mixing our fog color with this. So let's do that. Okay. Yes, and I believe that's what we want now because we're mixing our fog color with just whatever the light level is because we're not going to be using ambient lighting or anything like that. Okay. And that's giving us very strange result now. So let's double check that again too. Oh, I think it's because the diffuse, like the ambient light, was taking in texture stuff. Yeah, okay, so we need the object color to RGB. Okay. So the light color times the F color times the object's color, which if we look at the object's color, that is the texture. Yes, okay. So we'll do that, and let's see what we get now. Okay, so now we're getting the textures. Yep. And these are just the base textures, and then it should get darker. Okay, cool, yes. And then look, it gets darker a step here. And does it keep getting darker? Yeah, I think it gets darker a step here. It gets lighter again here, which is kind of weird. Why is that happening? I don't know. Then it gets darker here. It gets lighter again. And then darker here. And then lighter again. That's really weird. Is it like taking the light level above it or something? Because it should just be getting darker. And then eventually what's going to happen is it just, yeah, it gets completely dark. And it gets completely black. Okay. You think that's a chunk border again? It might be. You're right. Let's move over a little bit. I should have probably checked to make sure I wasn't in a chunk border before I did that. So let's do this. If I just dig straight down, that'll make sure we stay within a chunk. And it should still do the same thing. Whoa. And it's going to be completely black when I do this now because I'm not updating the lighting. We'll fix that in a minute too. I'm going to wait for it to finish generating, and then I'm just going to click for a while, and then we'll reload. So you can kind of see the chunk updating. I should probably add in some sort of optimization too for like multiple chunk updates in a row. Okay, that's about 32, right? I'll keep going a little bit further. Okay, I think that's good. We'll leave it there. So let's see now. It should just decrease in light level as it goes down. Where did I dig that hole? I think it was over. There it is. Okay. Oh, whoops. Oh, of course it's not going to... Yeah. Let's go back up because I have to add a block above this in order for it to go down. That way it's not skylight. Okay. So where was that hole? It's right there. So what we'll do is we'll do this and this. Okay, now it's not skylight, so it should get darker as it goes down. Let's try that again. Epilepsy warning. Uh-oh. Sorry about that. Okay, now we get, where is it? Here. I think it is getting darker. We'll fall in a minute. I'm just going to wait for all the chunks to finish. Oh, we'll fall in now. No, it doesn't look like it's getting darker. Yeah, it's definitely not getting darker, but it should be, right? Because this is, if it's taking the maximum of its neighbors, and it's not a skylight, which this should no longer be, then it should be getting darker as it goes down. And I know we're not hitting a chunk border because of that. Yep. Essie Woods, you're digging yourself quite the hole there, Gabe. Yeah. I wish it would be a dark hole too, but unfortunately it's not. Let's at least make this look nicer and make that dirt. No, I don't even know what dirt is anymore. Do I have dirt in here? I guess we can't even make this dirt. Oh, there we go. Okay. Cool. So that's a little bit better. And I'll make that dirt too. Okay. So what should happen here, right, is this isn't a skylight because we're blocking it. So this is not skylight. This one should take the maximum of its neighbors, -1. That would be 15, 15, 15. So this should be 14. This should also be 14. Then this one would take the maximum of its neighbors, which would be that one, and that should be 13. And then we should go from there. And it should just keep going. Or I guess 30, 31, 32, or 29. But it's not doing that. I'm trying to think if there's anything. Let's look at the algorithm again. So we check to see if it's a sky block. It's a sky block if its top neighbor is a sky block, which we're doing there, and the top neighbor is air. Or if the world height is 1 and it is air. Oh, maybe it's just because of this. Else if block data array expansion is an air block. Am I checking? Because we should only be doing this for air blocks. I'm not. I think that's probably what it was. As simple as that. Okay, let's run this again and see if we get the correct result now. Because that could be why it was like doing that weird updating too. We might have been within one chunk. Oh, sun direction is no longer used. We'll fix that. Whoa. Okay, so that just gets dark immediately too. Let's get rid of that warning real quickly. It probably shouldn't warn about that at all. Shader.cpp. The only reason I have that warning there is because one time I was like, why isn't this doing anything? And it's because it was gone. Because when you compile a shader, it'll optimize away variables and stuff. So yeah, let's do... Whoops. Warning. There we go. Okay, let's just get rid of this. Okay, so let's go back into here. I can't forget to add that back in. So let's make sure I remember to do that. Okay, let's see if this works now. So, oh, those are weird and dark. So I'm getting the wrong faces there, first of all. So I'll have to check that out. Does it get darker as you go down? I don't think it's getting darker as you go down still, right? Nah, it doesn't look like it. I'm trying to think if this algorithm is still good. Let's do this. Go back into here. If the block is not an error block, we'll just skip all of this. So we'll say if block data is not error block, continue. So we'll just skip all of that anyway. So then this would be true no matter what. Oh yeah, because then we do this whole light color thing. I don't think that should matter though. Yeah. So we skip that. That's all good. Then we don't even have to worry about this anymore because this is just true by default. Okay. And this is also true by default. Okay. All right. So now we should be good with all that. Let's see if this fixes it. If not, there's something else in our algorithm that's got to be wrong. So we'll do this. Let's see. Oh, okay. Well, that looks like it fixed whatever was going on with those blocks. They all look good now. Or maybe it didn't fix it. Maybe what ended up happening was it broke it even more. No, it still gets lighter and darker. Let's break more blocks and let's see if this maybe does get dark and I'm just not far enough down. Oh, wait, yeah, it does look like it's getting darker. Look. Or maybe that's just because of what I just did there. Yeah, I think that's just because of the fog. Never mind. Okay, that should definitely be 32 blocks at least, though. So it should get dark down there. Let's double check the algorithm again. So, top neighbor. We see if it's out of bounds. If it's out of bounds, we just set it to the null block. The null block is 0. So basically, yeah. And then what we do is we say if the top neighbor is an error block, well, null block is not an error block. If we look here, error block has an ID of 1, null block has an ID of 0. So they are not the same. So if it's an error block, then we take the light level and we AND it with 31. Otherwise, we take 0. So then the light level should all be good here, right? We do the same thing for the bottom neighbor. If it's y minus 1 is less than 0, that's good. Then we just take that value. Otherwise, we take this, okay? We do the same thing there. We do this for the left neighbor. That's all good. We do this for the right neighbor. That's all good too. Okay, then what do we do here? We say skyblock. So if the top neighbor is a skyblock or we're at the top level, then it's a skyblock, right? That's what we say here. And then we basically just set it appropriately. And then this is just setting the light color for all of them to white. Otherwise, we take the brightest neighbor minus 1. So that's the left neighbor, right, top, bottom, front, and the back. And if we take a look at this, that's taking all of those maximums, minus 1 or 0, whatever is bigger. So let's hit a breakpoint in here and see if this is working. We should hit this and it should get smaller a few times at least. Okay, yeah, so we are definitely hitting it. Left neighbor light is 0, 31, 0, 30, 0, 0. Okay. So wait, if we just go through this, this was 31, 0, 30. So what we should get is this should be 30. Which it is. Cool. So that's good. Okay, 0, 31, 30, 29, 0, 0. So this should be 30. That's good. Okay, that's all looking good. 30, 0, 0, 0. So this should be 29. It is. Cool. I think this is that spiral we had. I mean, it's got to be. But, okay, wait. Here we go. 12, 0, 0. So the bottom neighbor is 12. Oh, maybe this is why. But that shouldn't matter. I was going to say maybe this is why, because we are taking the bottom neighbors into account. And technically, since we're going top down, we shouldn't be taking the bottom neighbors into account. But if there's like a torch there, then that would change things. We'll figure that out later. That's a whole different story. Okay. Let's not take bottom neighbors into account for now. We'll do that. And we will remove this one. Okay, so that's good. Let's see what happens now. Because maybe that was throwing things off. Because, yeah, that's just... Okay, I think that might have been throwing things off, actually. Okay, so let's take a look now. There we go. That's definitely getting darker. Okay, it was getting darker until we hit a sub-chunk border. No, okay, so we hit 0 and then it reset. Okay, cool. So we are getting the correct things now. We just reset there, though. That wasn't good. Why did we reset? So we're taking the maximum of all of these and 0. So we subtract 1 and we say 0. So this should never be below 0. Let's just do a if. I'm just doing this so that we can hit a breakpoint in here. So let's do a breakpoint right there and see what's happening. Okay, that wasn't 32 blocks to get to 0, huh? Was it not? I'll have to... Oh, that could be it too then, if that wasn't 32 blocks to get to 0. Okay, so that says new light level is 0. So that's all good. What's the top neighbor? Top neighbor is 0. Okay, so that's just saying all of them are 0. What's top neighbor here? Nope, we don't care. Well, let me modify this. So if that's 0 and top neighbor is greater than 0. Okay. So now we should hit this once we start getting into whatever that loop is. Okay, so top neighbor is 1. This one is 0. Cool, so that's good. So now if we just do a breakpoint here, this should be like the next level down, possibly. Or actually, what I'm going to do is I'm just going to continue till we hit... So what Y level are we at? We're at 183. So if I continue to here... We are now at Y level 182. Okay. Oh, here, let me put a breakpoint in here. So now we should just hit the next block. Something weird's happening here. I think we're going through multiple threads is what's happening here. Because it's going crazy, our debugger. Yeah, I think this is going through multiple threads. That's not cool. Come on. Okay. So it thinks it's a sky block. No, I don't really know what's happening here. Are we in... No, we're in debug mode. Let's check what you said, VoxelRiffs, real quick, because it could be something as simple as just a shader miscalculation, because if we're not going to 32, yep. And Push Toy, I cannot believe you go below 0 in Minecraft now. Yeah, I know. That is pretty crazy, right? And as you can see, if they wanted to add that, then they probably had to do a massive restructuring of the way the code works to get that to work properly, because it's not easy to get working right. Okay, so let's see if we can count how many blocks this is. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So this goes down 14 and then it breaks. Am I dividing by the wrong number in my shader? So we do the light level over 32 plus the base light color. Yeah, this all looks right, I think. Let's turn up the base light color to like 0.9. Just to give that a little bit more. Actually, we'll do like 0.2. Or, yeah. Because right now it's just not very good. SE Woods, I can't say how many times I thought I found the solution to a problem and then running the application to see it working, but the issue remains. Yeah, it's sad. When you think it's almost there and then it's not quite there. Okay, so this means we shouldn't get like completely black blocks anymore, which is good. No, we are still getting completely black blocks. Is this going correctly? Oh, wait, yeah, and this is going to offset everything too now since we dug down there so that it happens here now. It's so weird, though, that we go like almost the whole way and then we just sort of break here. Yeah, very strange. And then it does it again. But it looks like this one is longer. And then we get a longer period of like darkness here. No, yeah, then it works this time. Wait a second. Okay, so. And we've got a spammer or something. Oh, no, not a spammer, but just like, yeah, we can ban that person in a minute. Okay, so it looks like it's working the second time around. That's really weird. It makes me think that this is definitely like a shader problem because the fact that it works and then it kind of breaks right here and then it continues again. Maybe it's because that guy was doing it based off of 16 and so he set this color to something. So let's think about how this is working. Okay, so we do color light level, light value, which we say is the float of the light level. What is the light level? It's whatever we pass in. Divided by 32. That gives us a number between 0 and 1 to the power of 1. Was he doing the power of 1? He was doing the power of 1.4. That could be a problem. Let's see what happens now. Okay. So okay, so it gets darker. Nope, it still gets lighter there. And I also have that hole, which is just completely dark. Yep, still gets lighter there. Right. Am I messing up somewhere in here? Maybe. Where like basically one of these is not taking the appropriate value. So top neighbor goes y plus 1. That's fine. Left neighbor goes z minus 1. Okay. And then we give it 0 if it's not an error block. Right neighbor, we go z plus 1. And then we give it 0 if it's not an error block. Front, we do x plus 1. 0 if it's not an error block. And then back, we do x minus 1. And we do 0 if it's not an error block. So that all looks fine to me. And we do want to be able to take the top neighbor's light level into account because that is important. Yeah, I'm not completely sure. What? Oh, you know what? Maybe it's because we have saved values. Let's do this. Let's delete this world and do a new world because it could be just loading bad stuff again. Is it overflowing the value? That's what I would normally think, but because I'm using a 16-bit integer there. So we shouldn't have that issue because like we still have a lot more bits than we would ever hit theoretically. But it's still a very real possibility. I'm going to try this real quickly because it might have just been deserializing bad values and then using those bad values to sort of make it stuff, right? So let's do this real quickly. I'm going to wait for the chunks to finish generating, and then I'm going to dig straight down again. Okay, so let's dig straight down for a while. And then after I dig straight down for a while, we'll check and see how far we've dug. Yeah, that should be plenty deep. Okay, cool. So then we'll save that. And if we run this again, and if this works, then I think I know where the problem is. Okay, so is it getting darker, first of all? Doesn't even look like it's getting darker. Okay, so now it's broken completely or something. I don't know. Okay, well, the fact that this is doing something different tells me that there is something we have to change. So first of all, when we deserialize blocks, okay, so we have this generate thing, and then when we deserialize, we need to make sure that we don't actually serialize light levels, because those have to be updated afterwards. So I'm trying to think of how the best way to do this would be. Let's just go, we'll copy this, and we will go into our deserialize function. Okay, after we do that, we'll go ahead and do this. And we'll say block data to 1D array XYZ dot light level equals 0. Okay, so we'll zero all of that out. That way, when we deserialize, it should not be using old block data. And then I'll probably eventually switch it so that we don't serialize that data at all. So we don't have to worry about this. Okay, so let's see what happens now. Okay, looks like we're still getting the same problem though, where it's not propagating downwards. Oh, wait, it's not propagating downwards because it's a sky block. Yeah. Oh, yeah, thank you guys. That makes sense. Okay, so we'll do that. And I have to make this dirt. I can't not make that dirt. Okay, cool. So let's save and then go back in. Okay, we go back in. No, we're still getting the same problem. Maybe it is block integer overflow. Yeah, because that is just... The reason I also don't think it's integer overflow is because it does it there, but then right here, it keeps going for way longer, and it doesn't break after that, which is kind of weird. Let's go back into there. Let's get rid of that. No, I can't go back to it. There we go. Okay. Okay, here we go. So we do all this, and then what do? We do -1. We're clamping it to 0. And the new light level, what is light level? It's a int 8. Oh, You're right. It is overflow. Duh. This should be the first thing I check. Oh, man. Is it? Wait, 2. Let's think about this, because the highest level it should go is 2, 4, 8, 16, 32, 64. No, yeah, the highest, we're only using 6 bits here. So theoretically it shouldn't. Oh, but wait, we're only using 6 bits here. But if we're using an 8-bit integer, this should be a uint8. It might be a interpretation problem. Okay, that might have been interpreting it wrong and then converting it to a negative integer implicitly. So let's try this again. And then it would like wrap around, and that's why we would get that weird stuff happening. Okay. Nope, we're still getting it, but that could be because it's wrapping around at a different point. Okay, so let's see. So this is definitely a uint8, and let's go back. I don't want to go into CPU usage. I don't know why it keeps taking me in there. Okay. So this, oh, and we should be doing new light level. Yep, so this takes in all of that stuff. Let's do this. If new light level is greater than, we have 8 bits, so 2 to the power of 8. Or it's less than 0. We'll break on that just to make sure we're not hitting integer overflow. So if it's ever greater than this or that, and we'll do 2 to the power 7, just because we're only using 6 bits, so we shouldn't even hit this. That would be bad. And then right here, what we'll do is we'll cast this to a uint8. And so I think that should cast it to the appropriate bits, because I don't think it should have to change anything, but it might. So we'll see. Okay, we are hitting this. So what is the new light level? 30. Is 30 greater than 2 to the power 7? What is 2 to the power of 7? I'm pretty sure that's, yeah, that's 128. So it definitely shouldn't be, oh, I'm shifting the wrong way. That's why. Shift left. Okay, there we go. We'll run that again. Pushjoy, look, you can't do proper bit shifting with camel case. Nah, that's not true. Okay, so there we go. We're not hitting any breakpoints, so that means we're definitely not overflowing. Yeah, so that's good. Let's look at our warnings, because I know I have some warnings in here that I haven't been taking a look at. So let's go show our warnings. So arithmetic, oh, so this is overflow. That's fine. I don't care about that. Okay, blockmap.cpp. I don't care about that either. And then these aren't even my code. Okay, here we go, chunk manager. So this is assigned, unsigned match. That's fine. Conversion, size t to float. That's fine too, because that's not even really being used. Okay, int to float should be fine. I can probably fix that too just by making that a float, so that should explicitly change it. Okay, yeah, and then all this stuff is fine. Okay, so there's nothing that should be like doing weird stuff. This is just strange. I know I said I would be streaming till we got this done, but this is just not working out right now, so I'm probably gonna have to debug this on my own time. Thank you everyone for coming and watching though. I'll be back tomorrow, hopefully with lighting done and working correctly. And then tomorrow we can finally work on cube maps and some other stuff in our to-do list, because we still have quite a lot of stuff to do. And I thought we'd be further along by now. We'll probably start working on biome generation for real, either that or transparency, because we have to get transparency working properly too. But yeah, So hopefully that will work. SE Woods, relax your brain a bit. Yep. Okay, guys, thanks for coming though. And I'll see you tomorrow if you're able to make it. All right, see ya.